I'm Borting Chen. I'm the intern of the real team. So I'm an intern at the Mozilla for 1 year since next summer. And my goal is to implement the resource statistics data. And this here shows the bugs I have worked on, which is 4 bugs. The first bug is implement the web idea, and the second bug is going to clear privacy data because for some privacy concern. And the last 2 bugs is focused on developing the power consumption metering. But I have the first objective I believe is I can Mozilla. And some after some discussion, move from the power statistics to the resource statistics at the end of last year. So that's why I implement the resource statistics. Okay, so let me brief the 4 bugs I have worked on. So the first bug is the web ID authentication relation of the resource statistics API. So the objective of this API is to provide the measurement of resource consumption and provide cost control. And we have 2 major results. We want to measure 2 results: the network and the power. So this API is somehow inherited from the existing network test API. And one of the goals of this API is to merge the network test. This API is the power test API into one single API. So first let me talk about resource consumption. In the resource consumption, we consider about 2 things. The first is which components is consuming the resource, and the second is who asks this component consume resources. So for components and for the network that consume network usage is the Wi-Fi and mobile. So for power that consume the battery, the power consumption is the CPU, Wi-Fi, or GPS, something like this. So for the second section, who asks those components to consume resource, and we have 2 targets. So one is application and one is system services. So in this API for resource consumption, we provide 3 methods, which are get states, previous states, and critical states. And these 3 methods take these variables, components, the app manifest UI and system type and as well as the time range, so that we can get the resource consumption in some time or clear statistics saved in our database. Okay, so the second goal of this API is to provide cost control. This is inherited from the network test API. So in cost control, we will allow users to set up a threshold to define how many resources you want to spend. So the resource statistics service will monitor resource usage, and when the resource usage is larger than the threshold, the resource statistics service will send user alert. So in this part, the API provides 4 methods which are used to set up alarm or get existing alarm or remove alarm from the database. So this is about the API implementation part. Okay, so for the second part, I consider about the privacy concern, because when the user remove the app from our backup store, and some statistics data are stored in the database. When some apps are removed, user will think that all related data are also deleted, or else someone may check the data to check back to which app he has used. So for this bug, I capture in this implementation I capture the web apps uninstall notification, and when I listen to this notification, I will get the API ID, so I can clearly relate the statistics from the database. Okay, so the third part and the last part is I'm starting to work on measurement of power consumption. So in this part, I will try to get the EID when an app is launched or terminated. And I also use an object to cache static data because I want to store the resource static data from report from other objects, from other components like CPU or Wi-Fi, and save them and sync them to a database at some point of time. So, for example, when I call the get statistics API, this will first sync the cache statistics to the database and perform the read operation. And for clear statistics, it will also first sync the data to the database and clear the related database sending database. So somehow this will work. We will find that sometimes we will cure a race condition because this database operation are a sync function. So we cannot guarantee this execution sequence. So I need to implement some method to guarantee to avoid race condition. So this is what I did. This is what my solution. In my application, I treat each API call as a request, and I will guarantee the execution, the all operation executed in this request in a sequence. And also, this request object will be assigned with a promise. And when an API call like we call the get states, we will record with request and the promise and push this request to the request queue. And when the operation in the get states are executed, this promise will be resolved. And the tricky thing is that when I have second request, I push this request to the request queue, and this request will find its previous request and set up its promise, its first operation as the resolve function of this promise. So when the execution of first request are done, so the promise is solved, and this will automatically execute the operation of the second request. And so the execution sequence are guaranteed. So and also avoid this condition. This is what I did in this third part. And the last part, I want to obtain the number of CPU ticks when how many number of CPU ticks that the app has spent. Because I want to capture this to calculate the power consumption, and this power consumption will be calculated by the number of CPU ticks and somehow depends on the pure frequency of the CPU. And I will capture the number of CPU ticks from the data structure of the states, the PID, and the STAT. And I will get the number of CPU ticks that the app has spent. But this box still has some problem that is when an app is closed, sometimes I cannot get the CPU ticks, the number of CPU ticks for that process, because this process may terminate before I call the read operation. So there's still some bugs here in the Chinese process. Okay, so there are some bugs I haven't solved. I'm sorry, but so at least those bugs are not solved here. And the first thing is that there are still some components need to be developed, for example, the power metering. And the second problem is how to merge the resource static database with level database. Because when merge these two database, somehow we need to move data from one database to another base, and this will be implementing upgrades, database upgrade. But we cannot guarantee that this moving data from the LSS database from LSS database to the result database can be complete, because the database operation are synchronous. So we cannot guarantee this operation can be complete before we start the next update function. So my colleague would suggest me that it would be better to further upgrade the LSS database and don't use the resources. LSS database and don't use the resource database or else I will miss someday when I do the merge function. Okay, so this is the end of my presentation, and in the past 1 year, I need to thank those guys who helped me a lot, give me some advice and help me understand the firewall system, because in architecture, some limitations, a lot of things, and sometimes they can also give me some review comments, and this review comments sometimes crushing me, and sometimes make me upset, but those comments are really, really good and make me improve my coding skills and make me more understand the firewall system. And the most important thing is that I learned from those guys that the most things I learned from these guys is how to co-work in such a big open source project. This is my first time joining such an open source project, and I'm glad I can have a lot. I can get a lot from you today, and also this is my first time to discussion with communities and some other privacy support. So thank you guys, and I have learned a lot. So for my next step, I will go back to my school and finish my studies. So hoping that we can see each other at the Mozilla someday.